Section 12.2, Measures of Central Tendency. We're going to be talking about average. The word average is a troublesome one when translating from English to math. And in math class, when you were young, we were first taught to find an average. You add up everything and then divide up by the number of things that you had. And we're going to get a lot more formal about this in a bit. The problem is that when we use the word average in English, we mean typical or generic. And although most of the time, the way we learn to compute average in math in elementary school will give you an answer that fits within our understanding of average in English, there are some times where it's just not going to work. If we have an outlier, some value that is extremely out of the norm, then it can really skew what we learned as the average, and it's not going to represent the typical anymore. So, for example, if Bill Gates walks into our classroom and I ask all of you to compute the average salary of the people in the room, do you imagine that the answer we get is going to fit within our English understanding of what average means? Probably not. Okay? The chances are that the average is going to be larger than all but one of us in that room actually makes. Okay? So a big outlier can skew that. So we need to have some other ways of talking about what we mean by average when we mean typical. Okay? We need some backups, essentially. We're going to learn about 4 different ways of talking about this. And we call these, in general, measures of central tendency. Or how do they go towards the middle? We need some definitions and notations. We use this letter, the Greek letter sigma. It's called the symbol of summation. And basically, it's a just big old symbol that says add everything up. The notation looks like this, sigma x, or the sum of x. It means that you should add all the data items within the set. So this is kind of like when we were talking about average up here, where you add them up and you divide them. This is that you add them up. Okay? Now, the kind of average that we were talking about in elementary school is more properly called the mean of the data set. All right, and so in statistics, the mean of a sample is symbolized by this, an X with a bar over it, and we do read that X bar. And if we're talking about the mean of an entire population, so not a subset, then when they use the lowercase Greek letter mu, which looks like this, and we're only going to be dealing with samples, so we only are going to be dealing with X bar for this course. Okay? Now, how do you compute the mean? It's the sum of the data items divided by the number of items. X bar is equal to the sum of X divided by N, where sigma X, or sum of X, is the sum of all the data items, and N represents the number of items. So this right here is the formal version of this. Now, the way the book is designed is I could work the same example problems over and over and over again, once finding the mean, once finding all the others that we're going to be talking about, or I can give you all the definitions and then we can compute on each example 4 times so we can easily see the answers. That's the way I've decided to go with this. That does mean, though, that we have a lot of definitions and things in the beginning. So I hope that you'll be patient. So if we're just given a small list of numbers, that's great. We know how to find the mean. Add them up, divide. But what if we're given that data in a frequency distribution and we have a whole lot of numbers? Well, there's a bit of a shortcut for doing this as well. And basically what we're going to be doing is you're going to be multiplying the value times the number of times it happens. So it's just a shortcut to the addition of the large things. We're going to work plenty of examples like this. But the notation, the x bar, the mean, is the sum of all xf, where x is the data value and f is the frequency. So instead of just adding the numbers, we have to do a multiplication first, and then we're going to add up those numbers. Okay? That's what they mean by this. And n is the total frequency. So that means we have to add up all of the frequencies, how many individual items there are. So this is like the other one. It's just our data is given to us in a different form, so we have to use a slightly different strategy. But essentially, we're doing the same thing. Okay? Now, like I said earlier, when we're trying to match math with English, most of the time, mean covers what we mean by average. Okay? But when it's wrong, most of the time you'll go with the median. Okay? And the median tends to adjust quite a bit for an outlier. All right, to find the median of a group of data items, you need to list all of them in order from smallest to largest. And then the median is the number in the middle. Okay? And if you have an odd number of items, then it really is going to be the exact middle. And because there will be one middle number in your list. If you have an even number of data items, then you're going to find the two middle numbers and you're going to find the mean of those. So you're going to average those in the elementary school sense of average. It's really hard to break yourself of that. Okay? Again, we'll be working examples with this. It can be, well, all right, first of all, one way of remembering this is, we talk about the median of a highway, and the median is in the middle of the highway, and the median is in the middle of our data set. They mean the same thing. Okay, so if we have a large data set, it's never fun to list everything in order. But we could also, it can be very useful if we just know where to look. If we have a long list, well, what position is it in? That would be a whole lot easier than pairing them off and trying to find out the middle. And this formula will help us do that. It only gives the position. Okay, so like it might tell us that the median is in the 12th position once we have everything listed in order. But it's not going to tell us what that value is. It's just going to go tell us where to look. And the way we do that, if n data items are ranged from the smallest to largest, the median is in the n plus 1 over 2 position. So, okay, and this works beautifully if we have an odd number of values, because like I said, there is one number in the middle. If there are 15 data items, then we would do, this is what we have right here. So I plug in 15 plus 1 to get 16 over 2, which is 8. So that tells me that once I have all these things listed in order, the 8th thing that's listed is the median. Okay? If the number of items is even, then we're going to have to take the average of those two numbers in the middle. So we use the answer that we get by this division. We're going to get a decimal. But it tells us where to look. It directs us to the two numbers we need to average. So, for example, if we had 16 data items and we plugged into that same formula, so then I get 17 over 2, which is 8.5. Since 8.5 is between 8 and 9, I'm going to go find the numbers in the 8th position and the 9th position, and then find the mean of those, and that's going to be my median. I know I'm throwing a lot at you. We are almost done and almost to the examples. Now our other two are mode and mid-range. The mode is the data value that occurs most often in a data set. Okay? And it's possible to have more than one thing showing up the same number of times. So if 8 appears 3 times and 9 appears 3 times, then I have more than one mode. It is also possible that everything appears the same number of times. If every entry only appears once, then nothing appears more than anything else, so we say we don't have a mode. Okay? Now, we have a special name for a set that has two modes. It's called bimodal. I have not heard of any other special name for any other number of modes, but bimodal means two modes. Okay? So that's just, what's happening most often here? The mode. Mid-range of a data set is found by adding the lowest and the highest data values and then dividing the two. So you take the largest and the smallest and you find the mean. So it's kind of like finding the mean, except we don't worry about any of those middle numbers that are getting in the way. Okay? All of these can give us a basic idea of what is in the middle.